Hey everybody, Mr. Gajewski here. Welcome back. Today we're going to be talking about 2.1.4, what makes a zero. So we are going to deepen our understanding of the concept of zero, and we'll learn how to represent zero in multiple ways with algebra tiles. We're also going to build on how to simplify algebraic expressions using tiles. So using zero to simplify algebraic expressions. Today, you will continue your work with rewriting algebraic expressions as you work with your team. Ask yourself and your teammates these focus questions. How did you see it? How can you write it? Is your expression as simplified as possible? Now, even if you're not working as a team, you can go ahead and as you're working, think about these as you try the problems. So, 234, likely story. Imagine the following situations. Julie babysits her neighbor's baby and stuffs the $15 she earns into her purse. When she gets home, the $15 is nowhere to be found. It must have fallen out of her purse. The Burton Pumas football team completes a pass and gains 12 yards, but on the very next play, the quarterback holds onto the ball too long and gets sacked, losing 12 yards. You're at the beach. You dig a hole in the sand and place the sand you remove in a pile next to your hole. Someone comes along and pushes the pile back into the hole. What do each of these situations have in common? Can you represent each of them using symbols? How? Pause and take a couple seconds to think about that. All right, so each of these situations deals with equal opposites so that the net effect is zero. They can be represented with equations such as $15 minus $15 equals zero. 12 minus 12 equals 0 yards, and negative x plus x equals 0 if x represents the level of the sand above sea level. So let's move on to 235. How can you represent 0 with tiles on an expression mat? With your team, try and find at least 2 different ways to do this, and more if you can. Be ready to share your ideas with the class. So you will not have a teammate, you will not be sharing with the class, but go ahead and see if you can come up with multiple ways using an expression mat. So a quick refresher, I'm going to exit full screen, eTools, tiles, backgrounds, expression mat, plus minus, and I have my tiles here. So go ahead, think of a way that you can represent 0. All right, welcome back for everybody who paused the video. So let's go ahead and let's think of a way. Well, if I have 1 here, 1 minus 1 is equal to 0. We could also say 1 plus a negative 1 is 0. Minus 1 minus a negative 1 equals 0. And plus a negative 1, well, let's see here. Yeah, plus a negative 1 minus a 1. Nope, that's not going to work. That's going to give me, it's going to give me negative 2. So I have to make this negative, right? Adding a negative, taking away a negative, I get 0. I can also use different amounts. 2 minus 2 is 0. 3 minus 3 is 0. There's an infinite number of ways that we can make a 0 using tiles. We can do the same thing with the variable tiles as well. Go ahead and dump these. All right, back to full screen here, 236. Gretchen used 7 algebra tiles to build the expression shown below. Build this collection of tiles on your own expression mat or use eTool 236. Let's go ahead and let's open up the eTool here. All right, that expression is already made here. Then we want to write its value. All right. So let's go ahead and let's take a look here, and I'm going to go ahead and annotate. I have 2x plus a negative x plus 1 minus 1, 2, 3. All right, now we want to represent the same value in 3 different ways, each time using a different number of tiles. Be ready to share your representations with the class. Pause the video, try on your own. All right, welcome back. Let's go ahead and let's take a look here. So I'm back in the 236 eTool. So again, I want to use a different number of tiles here, okay? So if I add an x, in order to keep it equal, I could also subtract an x. Another way I could think about this is if I add an x, I can also add a negative x. I could add 2 x's and add 2 more negative x's. These are all going to have the same value as this expression. The opposites cancel each other out. 237, build each expression below so that your representation does not match those of your teammates. Once your team is convinced that together you have found 4 different valid representations, sketch your representation on your paper and be ready to share your answer with the class. So you will not be working with a partner. So what I'm going to have you do is use the math, see if you can come up with a way to represent each of these expressions, and then see if you can come up with a second way. I'm not going to have you come up with 4, just come up with 2 different ways. Pause the video, try each of A, B, and C on your own for 237, and then check the video. All right, welcome back. So A, minus 3x, negative 3x, means the same thing though. Negative 3x plus 5 plus y. So let's go to an empty sheet. Minus 3x. So in the minus section, I'm going to put 3 x's. Plus 5.
In 5 minutes, we will be starting our EA training, focusing on the moat extension to make comments with students and turning PDFs and images into interactive sheets with students. If you are interested in joining us, anyone is welcome to join. Again, it's 5 minutes in the library. Thank you.
Well, I'm not interested, so I'm not going to join. So anyways, moving on. Here is a way that we can build this. Now again, I also want you to sketch on your paper this as well. And then what's another way that I could build this? Well, the opposite of adding a y is taking away a negative y. That's another way. I'm not going to make you sketch both, but sketch one way, build 2 different ways. All right, minus negative 2y plus 1. So I'm going to subtract the whole thing. So in the minus section, we're going to take away 2 negative y's, so minus 2y. I'm just going to close that. Minus a positive 1. Minus a positive 1. Build it, sketch it. Let's take a look at the next. Plus 2x minus x minus negative 4. Minus negative 4. Okay, hopefully you're able to build that. See if you can build it another way. Go ahead and sketch this, and we will move on. All right, 238. Write the algebraic expression shown on each expression mat below. Build the model and then simplify the expression by removing as many tiles as you can without changing the value of the expression. finally, write the simplified algebraic expression. So go ahead and pause the video, try it on your own, and then check back, and I will walk you through it. All right, write the algebraic expression shown on each expression mat below. So we're going to go ahead and write the expression right here. Well, I see plus an x plus a negative 2x plus a negative 2 minus a negative 2. So let's go ahead and let's build that. All right, x plus a negative 2x plus a negative 2 minus a negative 2. So when I go ahead and build it, it's going to look like this. All right, after building, all right, we want to simplify the expression by removing as many tiles as we can without changing the value. All right, so I'm going to see what I can take away here. Now, if I have an x and a negative x, those two cancel each other out, we can remove it. Let's look at the plus and minus regions. If I add a negative 2 and then I take away a negative 2, those will cancel out. All right, what is left over? Plus a negative x or a negative x. So my simplified answer, negative x. Let's go ahead and let's take a look at b together. So I see plus an x plus 1 plus a negative x and a negative 2 minus x minus a negative 3. All right, if I want to build that, right, x plus 1 plus a negative x plus a negative 2. And then I'm going to take away an x and a negative 3. So minus x and minus negative 3. All right, let's go ahead and let's simplify. All right, well, 1 plus a negative 1 cancels out. X plus, took too many there. Negative x and x cancels out. All right. Another way we can think about this, well, nope. So if I'm adding an x, if I'm adding a 1 and I'm taking away a 1, these guys are going to cancel out. And what is left over? Well, I have a minus a positive x and minus a negative 2. Let's go ahead and flip these. Right, so taking away a positive x is the same as adding a negative x. Taking away a negative unit is the same as adding a positive unit. So what is left over? I have a negative x and a positive 2. Right, that's 238. Let's go ahead and let's take a look at 239 together. Or not. All right, now we're good to go. 239, simplify each of the following expressions by building it on your expression mat and removing the zeros. Your teacher will give you instructions about how to represent your work on your paper. So we're going to start by building 3x minus 2x minus 2x, right, plus 4. Excuse me, minus a positive 4, so minus a positive 4. All right. Another way that we can think about solving these, actually I should write this down, so 3x minus 2x plus 4. All right. So that's how I want to write it on my paper. I've built it, I've written it on my paper. All right, what are some ways that we can simplify here? So let's think about opposites here. All right, so if I want to distribute this negative here, all right, what's that going to give me? All right, that'll give me 3x minus 2x plus 4. All right, what is that going to look like on my tiles? Okay, so I'm adding the opposites, right? The minus 4 becomes plus a negative 4. And now this is the other way I wanted to talk about with how I can take away zeros. So I can flip everything from the negative region into the positive region. And when I flip them, I have to change the signs from positive to negative, and then I can make my pairs. X and negative x cancel out. X and negative x cancel out. What is left over? I have an x and 4 negative, so x minus 4. I have an x and a minus 4. 239b. All right, let's use that same method here. So I have 7 minus 4y minus 3, minus a negative 3. Minus 4y minus negative 3. So I'm taking away negatives by putting them in the take away region, right? Plus 2y minus 4. Plus 2y minus 4. Actually, let me think about this. Minus 4, let's put minus, right? Minus a positive 4 in the lower region. So again, one of the ways that we can do this is we can flip everything from the negative region up into the positive region and then change the signs. So when I take them from negative into positive, I need to change the positives to negatives, negatives to positives. So that'll look like this. All right, now I can make pairs of positives and negatives. But I should write this down first. So now what do I have? Okay. Well, what did I do? I flipped the signs of my negatives. I distributed that negative. So the minus 4y becomes minus y, or minus 4y, in the positive region. So 7 minus 4y. The minus a negative 3 became plus 3. Right? And then I have the 2y. I actually have plus a negative 4, which is the same as minus 4. Let's go ahead and let's make our pairs. So we're making zeros now. Cancels out. Cancels out. We have some y's left over. All 1, 2, 3, 1, 2, 3. These 3 minus 3 cancels out. So what's left over? I have negative 2y plus, let's see how many positives I have here. 1, 2, 3, 4, 5, 6, 7. And there's my final answer there. So 240, that's learning log. 240 in your learning log, describe the different ways you can represent 0 using your expression mat. Include an example and be sure to draw the tiles. Title this entry, Using Zeros to Simplify, and include today's date. Take about 2 to 3 minutes to work on that. When you're done, go ahead and take a look at the homework. The homework, once again, is going to be all the review preview problems. I'm going to start at 241, go all the way to 245. And that is it for today. Thank you for watching. Smash like and subscribe, and I'll see you next time.